Good morning, chemistry students. Here's the teaching video for your Chapter 5 notes, Day 5. This is actually the last day of your Chapter 5 notes. So we're starting at the 5.4, the periodic table, organizing the elements, and we're going to go to the end. We're going to talk today about the periodic table, what information you see on the periodic table, how it is organized, and the different types of elements on the periodic table, and some special names for areas or parts of the periodic table. So we're starting with 5.4, the periodic table, organizing the elements, and the modern periodic table. On the modern periodic table, the elements are arranged in order of increasing atomic number. So again, looking at your periodic table, right, how do we know which number on the periodic table is the atomic number? Remember that the atomic number has to be a whole number. So here are our whole numbers. So on this periodic table, okay, the atomic number happens to be in the lower left-hand corner. However, it's not always where it is, but I can always tell where my atomic number is because it's that whole number that the elements are organized by. So our modern periodic table is in order by increasing atomic number. Remember, that was Henry Moseley that did that. So what's on every periodic table? Well, the things that we see on every periodic table, we always see atomic number. We know which one's the atomic number because it's going to be a whole number. It's equal to the number of protons, right? So atomic number tells us the number of protons. And it's also the number of electrons in our neutral atom. Another thing that's on every periodic table is we have the element symbol. The element symbol, always the first letter is a capital, and all others are always lowercase. So we already looked at atomic number, but we see the element symbols here, okay? And again, we see a capital letter followed by a lowercase letter. So you need to be careful if you're a drafting student, because sometimes in drafting you're taught to use all capitals. And so sometimes I would see somebody write like the symbol for selenium as a big S and then a capital E but smaller. I would mark that wrong because technically the chemical symbol has to be a capital S and a lowercase. Okay, so be careful if you happen to be a drafting student and you've learned to print in all caps. Another thing that's on all periodic tables is the average atomic mass, which is usually a decimal number. So again, most periodic tables do have a key on them, but let's say you're looking at periodic table and can't see the key, like in this one. Again, I'm going to know which number is my average atomic mass because, again, It's my big, long decimal number. In this case, it happens to be underneath the element's name. Okay. Again, remember, these are decimals because we talked about that on our notes just yesterday. We talked about the fact that that takes into account all of the naturally occurring isotopes, what the mass of each of those isotopes is, and what their natural percent abundance is. So that's why they're not whole numbers. We also on periodic tables sometimes see the name. Probably most of the periodic tables that you're going to come across are going to have a name on it. Okay, so again, we see that on this periodic table with, for example, gallium. Okay, at this periodic table, it happens to be at the top, but again, they can be in different spots on the periodic table. Notice again, the number that's not here, remember there's no mass numbers on the periodic table. Okay, mass number, remember, is the total number of protons and neutrons added together. And these numbers, okay, the one that I circled in blue, the average atomic mass, that is not the mass number. Remember that the number, the atomic number, which is circled in green, remember the atomic number does tell you the number of protons. And the other thing that we're going to discover as we move into chapter 13 next is that the periodic table also, because of the way it's organized, there's also information about the structure of the atoms. So you get a little bit of that information by knowing the atomic number, okay, because that's telling you how many protons are in the atom. But you've noticed that every periodic table kind of looks the same. There's 2 tall columns on the left. There's 10 short columns next. Then there are 6 tall columns on the periodic table. There are 2 rows down underneath. That is because, and you're going to learn why that is, that's telling you information about the structure of the atom. So by the time you finish this unit of chapters 5 and 13, you also will probably look at the periodic table very differently and start to see some of that structure. So, part of the structure of the periodic table, though, is that the elements are organized into periods. The periods are the rows that go horizontal. Right? So they're kind of the left to right. So, this is part of one period. This is part of a different period. Okay? So, again, we see periods on the periodic table. So, you should be looking at a periodic table because I'd like to know how many there are. So looking at your periodic table, decide how many rows are there on your periodic table. Are there 7 or are there 9? Hopefully you answered 7, because if you look at the numbers for the 2 rows that are at the bottom, you'll notice that those numbers would actually fit in the 6th and the 7th row from the top, in between lithium and hafnium, and between actinium and rutherfordium. Okay, so those two rows are actually pulled out of the main body of the periodic table to make it fit better on a piece of paper and placed underneath. So there actually are only 7 of them. The elements are organized in such a way that the properties okay, change across a row across a row or a period as you move from left to right, but the pattern repeats as you move from one period to the next. So this comes, or kind of is prepping you for this idea that there is a periodic law about the periodic table. And that periodic law says that when elements are arranged in order of increasing atomic number, there is a periodic, or kind of repetitive, if you will, repetition of their physical and chemical properties. Okay, so all that's saying is that when we have these elements organized in order of increasing atomic number, what tends to happen, or what happens, is we have elements that look like each other and act like each other near one another on the periodic table itself. So again, what this means is that elements with similar properties I don't know if you guys can hear her, but my dog's driving me crazy, licking and chewing at her foot. So these elements with similar properties are in the same column of the periodic table. So because we have these elements organized in order of increasing atomic number, and because elements that are similar to each other in terms of what they look like and how they react chemically end up near one another on the periodic table, we're going to find that elements that have similar properties are actually in the same column of the periodic table, which brings us to talking about groups or families, which are the special names for the columns on the periodic table. Okay, so again, the groups or columns here, and this is part of one group or family. Here's another part of one group or family. Those are the columns that run up and down on the periodic table. So, same question. How many are there? That should be a little bit easier question to answer because typically they're numbered. There are 18. Again, these groups or families, so these columns are elements with similar chemical and physical properties. And these groups or families are identified by either a number or a number and letter, depending on the periodic table. So depending upon what periodic table you have, you'll either see all the groups and families, again, all of those columns, either having a number above the column or a number and a letter. Okay, and sometimes that can actually tell you a little bit about the origin of the periodic table. Sometimes those numbers are a Roman numeral. Okay. Or if it's just a number, it tends to tell you that the periodic table originated in Europe. Because in Europe, kind of typically they just use a Roman numeral, okay? Or just numbers, and usually that kind of means it's from Europe. When you see a number and a letter, that often is telling you it's from the United States. Okay. So when you also have just a number, sometimes it is a periodic table that was published by the International Union of Pure and Applied Chemistry, which is sort of an international group that oversees chemistry, okay, which is abbreviated IUPAC. So again, depending kind of on the origin of the periodic table, you might sort of see it labeled, the groups or the families labeled a little differently. Sometimes you'll have a Roman numeral in a letter, sometimes you'll have just a number, sometimes you have like a number like we think of and a letter. And again, it just kind of tells you a little bit about maybe where that periodic table started out. So we want to talk about Group A. These are the tall columns on the periodic table. So if you're looking at a periodic table that has both the number and the letter, okay, you'll notice that the tall columns will have the letter A behind them and the short columns will have the letter B. These tall columns on the periodic table, these are called the representative elements. I'm going to have to chase my dog out of here because she's driving me insane. Hold on a second. Sorry about that if you could hear her. She was driving me crazy. She was either licking, scratching, I don't know, doing a bunch of different things that for whatever reason are annoying me right now. So, the Group A elements, those are those tall columns on your periodic table. They're the one, you'll look at the tau columns again, they'll have a number and a letter behind them, and the letter they have is an A. These are called the representative elements. Okay. And these representative elements, and all of the elements really on the periodic table, are broken into three broad classes. Basically a way that we could sort all of the elements on the periodic table based on their general properties. And basically, as you move across a period, which remember is the special name for the rows on the periodic table, the properties become less metallic, and more non-metallic. So one of those three broad classes of elements that we can sort all those elements on the periodic table into are the metals. In fact, most elements are metals. About 80% of the elements on the periodic table can be classified as metals. Now, at some point in the past, you have probably learned about the properties of metals, and typically considered the very most important property of metals is the fact that they are generally good conductors of heat and electric current. That's typically why your pots and pans that you cook with are made of metal, because that metal conducts that heat really well to whatever the food is that you're trying to cook in the pan. Another property of metals is that they have what is called a high luster or sheen, because the element reflects light. So basically what this is saying is that metals tend to be shiny. And they're shiny because the light hits them and it bounces off of them. For the metals, all of them except mercury are solids at room temperature. So all of the metals on the periodic table are in the solid state of matter when they're at room temperature, with the exception of mercury. Another property of metals is that they are what is called ductile, which means that they can be drawn into wires. And basically all that's saying is that you can have a big chunk of a metal, and with a machine, you can't do it yourself like with your hands, but with a machine can pull on the two different ends of that big block of metal, and it can pull it and pull it and pull it, and it can pull it into a wire. Okay, so that's what we mean by being ductile, is that a big chunk of these metals can be pulled into a wire. which is the reason why most of your wires that you see are made of metal. Another characteristic of metals is that they are malleable. Now, to kind of think about what that means, think about the term mallet, right? You might use a mallet in band class, and you actually might use something that could be considered a mallet in wood shop. Okay, a mallet is another word for a hammer. Okay, so what we mean by malleable is that metals can be hammered or pressed into thin sheets without breaking. So malleable means that these metals can be hammered into thin sheets without breaking. That's why many early civilizations ate out of and put their food in, okay, a metal container. Because again, I can have a big chunk of metal and I can hammer on it and I can shape it and I can make it thin. So now that you know some properties of the metals, where do you find them on the periodic table? The metals are on the left side of the periodic table. Okay, so you're going to find the metals on the left side. So basically what you're talking about is, if you look at the periodic table with the way it's just numbered, you're looking at the groups or families 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, all being metals, okay, for the most part. And then a couple more, kind of the lower parts of rows 13, 14, 15, and 16. Okay, so generally the left side of the periodic table is where we say we find the metals. The second broad class of elements that we can kind of sort all of the elements on the periodic table into are the nonmetals. We'll start by talking about where we find these on the periodic table. These are on the right side of the periodic table. And oftentimes we say they're to the right and above the heavy stair-step line. So that stair-step line I'm talking about, you see right here. Sorry. See this heavy stair-step line? That's the line we're talking about. So as it goes down the periodic table, okay, it continues and it kind of looks like a set of stairs. Okay? This side and below that periodic table, these are metals. Above and to the right of that stair-step line are the non-metals. Okay, so you'll want to find that heavy stair-step line, and if it's not really clear on the copy of the periodic table you're using, you might want to make it a little bit darker and easier to find. Now, the nonmetals have a lot more variation in their physical properties, meaning they don't often look like each other. Oh, I have too many T's in there. But generally, they tend to have properties opposite those of metals. So they tend to be sort of the opposite of metals. And remember, for metals, we said that most important property was that they were a good conductor of heat and electric current. So realistically, the most important property of nonmetals is that in general, they are poor conductors of heat and electric current. Okay, so metals on the left and below that heavy stair-step line. The nonmetals are to the right and above that heavy stair-step line. The important property about metals is that they are good conductors of heat and electricity. The important property about nonmetals is that they are poor conductors of heat and electricity. Our last category, our last broad class of elements that we can sort all of the elements into are the metalloids. And the metalloids are most of the elements that border that heavy stair-step line. That separates the metals from the nonmetals. Generally, they are the metalloids. So what we're talking about here is oftentimes silicon is considered a metalloid. Sometimes arsenic is, because they're touching that heavy stair-step line. Okay, so typically metalloids are going to be elements that are touching that heavy stair-step line. They can really be on either side of it. Metalloids are kind of interesting because they generally have properties that are similar to those of metals and nonmetals. So what that means is that under some conditions, the metalloids will act like a metal, and under a different set of conditions, the metalloids will act like a nonmetal. So that makes them sometimes quite useful. Okay, so what this means again is that in some conditions, they behave like a metal. And under other conditions, they behave as a nonmetal. And again, because of this important property, metalloids have a really important use. They're used in electronic devices, so your Chromebook, your phone, any kind of tablets you have. They're used for the computer chips because they conduct the electric current that they need to, like a metal. But part of the problem with metals is that when they conduct that electric current, they also get really hot. Well, because they use a metalloid instead in those electronic devices for their chip, they will conduct that electric current, but they don't tend to get as hot. Okay, so they don't follow that property of metals where they get hot, and so they're better for use with a Chromebook or a laptop or a computer or your phone that you're carrying around, because you don't want it to get so hot that it explodes or that you can't hold it any longer. So metalloids are used in electronic devices. Probably all of you own something that has metalloids in it. So remember we talked about the fact that the group A elements were the tall columns on the periodic table. The group B elements are the short columns, or groups or families, on the periodic table. And the group Bs are mostly metals. So there are some groups on the periodic table that have some special names. Okay. So group 1A or 1, depending upon whether your periodic table is numbered with a number and a letter or just a number. These are called the alkali metals. Group 2A or 2 are called the alkaline earth metals. Group 7A or 17 are called the halogens. Now you might have heard of the last two. You might have heard of alkaline or even alkali with respect to batteries. And you might have heard of halogen before with respect to lights, particularly really bright lights. So sometimes cars are manufactured so that their headlights are a halogen headlight. Okay, because halogen lights are brighter. Another group with a special name is group 8A, 18, sometimes actually numbered 0 on your periodic table. These are called the noble gases, or sometimes they're called the inert gases. Inert just means they're unreactive, and you will learn why it is that they are considered unreactive as we move forward. The group B elements, so those short columns, or groups 3 through 12, okay, those are called the transition metals. Those are those short columns in the middle of the periodic table. And then the elements that are below the main body of the periodic table, so those two rows that are pulled out and put underneath the rest of the periodic table, Those are called the inner transition metals, or they're sometimes called the rare earth metals. Now, you'll find that in modern times, typically they're more often referred to as the inner transition metals because rare earth is actually not true. Initially, scientists and chemists thought that these elements were not very common in the soil on Earth. However, they've discovered that that was not true. So oftentimes, they're kind of trying to stop calling them the rare earth metals because that makes it sound as if they don't exist, right, in the earth, but they actually do. So that brings us to the end of chapter 5. Your homework, again, remember I've kind of showing you here how your paper should be set up. Remember, you have two choices about how you do your homework. You can type your homework in a Google Doc, or you can handwrite your homework on a piece of paper and take a picture of it and upload that picture to your Google Drive. Once you either have typed up your homework or uploaded your picture to Google Drive, you need to find homework number 3, the homework number 3 assignment in your classwork tab of your Chemistry 1A Google Classroom. When you find the assignment, you want to view the assignment, and then up in the upper right hand corner there should become a plus mark where you can add either that Google Doc, okay, or your photo. And after you've added it, you need to make sure at the very end that you click submit. So homework number 3 is on page 126. You're going to answer questions 28, 29, and 32. Have a great day. I will see you or talk to you tomorrow.